Ever wonder what really happens when you make a phone call today? It might seem simple, just tap a name and start talking. But behind the scenes, a fascinating digital journey unfolds every time you connect. Gone are the days of crackly landlines. Now your voice becomes digital data, zipping across the internet at incredible speeds, often with crystal clear quality. This is Voice over Internet Protocol, or VoIP, the technology powering WhatsApp calls, Skype, and most office phones. It's what lets us talk to anyone, anywhere, using just an internet connection. It's fast, cheap, and global. With VoIP, you can reach friends and colleagues across continents in seconds, breaking down barriers that once made international calls expensive and rare. But there's a catch. Anything sent over a network can be intercepted. The same openness that makes VoIP so powerful also introduces new risks. Think of the internet as a massive postal system where millions of messages are sorted and delivered every second. Your voice is split into digital parcels, packets, that travel through countless routers and switches before reuniting at their destination, often in the blink of an eye. This process is lightning fast, but it opens the door for eavesdroppers. Anyone with the right tools and access can potentially listen in. If you're on an unsecured network, like public Wi-Fi, your digital parcels could be read by anyone nearby, making your private conversations vulnerable. This is called packet sniffing, a technique used by both network admins and hackers to monitor or capture data as it travels. The unsettling truth? Private conversations can be captured and replayed, sometimes without you ever knowing. Our goal isn't to teach mischief, but to show you how these attacks work, so you can defend yourself and your loved ones from digital threats. We'll explore the tools hackers use, from specialized software to clever tricks that exploit network weaknesses, see how a call can be intercepted in real time, and, most importantly, learn how to protect your conversations with simple but effective security steps. The openness that makes the internet powerful also makes it vulnerable, exposing us to new kinds of risks. By understanding the risks and how these attacks happen, you can keep your private calls truly private and stay one step ahead. Knowledge is your best defense, so let's dive in and empower you to communicate safely in the digital age. Meet Wireshark, the ultimate network protocol analyzer, trusted by network professionals and cybersecurity experts worldwide. It's like X-ray vision for your Wi-Fi, letting you see every packet of data flying by, whether it's emails, web browsing, or voice calls. Network pros use it to troubleshoot and secure networks, but hackers use it to snoop, intercept, and analyze sensitive information. Then there's Linphone, a popular open-source VoIP app that lets you make free internet calls from almost any device. It's our victim in this scenario, but it could be any soft phone or VoIP application you use at home or work. Linphone uses SIP, a standard protocol for internet calls, which is widely adopted by many communication apps. Millions rely on apps like this every day for business meetings, personal chats, and even international calls. Here's the setup. A hacker joins the same Wi-Fi as their target, runs Wireshark, and captures all network traffic, including VoIP calls and messages. No need to hack devices, just listen to the open airwaves, especially on unsecured or public Wi-Fi networks. Remember, these tools aren't evil. It's how and where they're used that matters most. Like a lockpick, Wireshark can help or harm, depending on the intent of the user. We're showing you the burglar's tricks so you can reinforce your own locks and protect your digital life. Understanding the tools is the first step to defending against them and staying one step ahead of attackers. Let's see how the attack unfolds and what you can do to stay safe. How does VoIP actually work? When you speak, a codec chops your voice into digital packets. Each packet is a mini envelope with a piece of your voice and some routing info. These packets travel different routes across the internet, dodging congestion and obstacles. At the other end, your friend's device reassembles the packets in order, filling in any gaps as best it can. This all happens in milliseconds, creating seamless conversation. The vulnerability? While packets travel the local network, like public Wi-Fi, They're visible to anyone listening. If unencrypted, it's like sending postcards anyone can read. Hackers with tools like Wireshark don't break in. They just read what's out in the open. Encryption is the only thing that turns those postcards into sealed letters. Let's see how hackers exploit this weakness. The hacker's first move? Get on the same public Wi-Fi as their target. Think coffee shops, airports, hotels. These networks are often open or use a shared password, making access easy. Once connected, the hacker sets their network card to promiscuous mode, capturing every packet, not just those meant for them. With Wireshark running, their laptop becomes a digital net, scooping up all data web traffic, emails, and, crucially, VoIP calls. No need to target anyone specific, just capture everything and sort it out later. For a demo, the hacker might use 2 laptops to make a LIN phone call, while a third laptop captures the packets. This setup mimics a real attack. The hacker silently records the conversation between 2 unsuspecting users. The victims have no idea their call is being intercepted. The stage is set for eavesdropping. With Wireshark running, the hacker watches a flood of intercepted packets stream across the screen in real time, each one representing a tiny piece of digital communication traveling through the air. Most of what appears is just noise, mundane web browsing, emails, and endless background chatter from devices constantly talking to the internet. The real challenge is filtering out the clutter and zeroing in on the valuable VoIP traffic hidden among the chaos. VoIP calls rely on specific protocols: SIP for call setup and signaling, and RTP for carrying the actual voice data back and forth between callers. The hacker types RTP into Wireshark's filter bar, instantly narrowing the view to just the voice packets, cutting through the digital noise. Now, only the call's audio data is visible, showing the source and destination IPs, sequence numbers, and codec type used for the conversation. The hacker lets the call continue, capturing thousands of these packets, each one a fragment of the ongoing conversation, steadily building a complete record. When the call ends, they stop the capture and save the file, a comprehensive digital record of everything that was said. The callers remain blissfully unaware. To them, their conversation seemed private, secure, and completely uninterrupted. But every word, every laugh, every secret shared is now stored on the hacker's computer, ready to be replayed or analyzed at any time. The ease and invisibility of this attack is what makes it so dangerous. No alarms, no warnings, just silent observation. Next, the hacker will use these captured packets to reconstruct the call, turning raw data back into a human voice, revealing the conversation in chilling detail. Now the hacker has thousands of RTP packets, tiny audio fragments. Wireshark's built-in tools make reassembly easy. The hacker selects VoIP calls in the menu. Wireshark identifies the call, showing start time, duration, and protocols used. With a click, the hacker opens the RTP player, which lines up the audio streams for both sides of the conversation. The player puts the packets in order, decodes them, and prepares them for playback. What was once a shredded book is now a readable story. The hacker is seconds away from hearing the entire conversation. The technical barrier is shockingly low. The hacker hits play, and the captured voices come through clear as day. "Hello, can you hear me?" "Yes, loud and clear." Every word, every pause perfectly preserved. The hacker can rewind, replay, or save the audio as a standard file. What started as a private call is now a simple recording. The quality? Often indistinguishable from the original. No hacking into devices, no passwords needed, just public tools and an open network. Imagine if this was a confidential business call, a legal discussion, or a personal conversation. Most people assume their calls are private, but on many networks, they're public broadcasts. The ease of interception is a wake-up call for anyone who values privacy. Let's talk about why this matters. This isn't just a technical trick, it's a real threat to everyone's privacy. We discuss sensitive topics on calls: health, finances, relationships, business secrets. The idea that a stranger could record these conversations is disturbing. For businesses, the risks are huge. Corporate espionage, stolen strategies, leaked client info. For lawyers, doctors, and journalists, intercepted calls could mean legal trouble or lost trust. Hackers can use captured info for fraud, social engineering, or phishing. Even small details from a call can help them break into your accounts. VoIP is everywhere now: home phones, office systems, messaging apps. Many services use encryption, but if your call isn't secured, it's vulnerable. Assuming you're safe on public Wi-Fi is a dangerous gamble. So, how do you protect yourself? The answer: encryption. Encryption scrambles your voice packets, making them unreadable to eavesdroppers. Even if a hacker captures your call, all they get is static. Avoid public Wi-Fi for sensitive calls, or use a VPN to create a secure tunnel for your data. Choose apps with end-to-end encryption, like Signal, WhatsApp, or FaceTime. For business VoIP, enable security features like TLS and SRTP in your settings. Keep your apps and devices updated for the latest security patches. Make important calls on cellular data or trusted, password-protected Wi-Fi. By taking these steps, you turn your digital postcards back into sealed letters. Protect your privacy, because your conversations should stay yours.